Have you ever wondered what makes IPv6 address types unique and why they are crucial in network engineering? Well, wonder no more. Today we're diving into the world of IPv6 address types and their importance in network communication. IPv6, or Internet Protocol version 6, is designed to replace IPv4, the current standard for Internet addressing. The primary reason for this shift is the sheer volume of addressable devices in the world today. IPv4 simply can't accommodate them all, but IPv6, with its vast addressing capability, can. Now, there are three main types of IPv6 addresses that you should be familiar with: Unicast, Multicast, and Anycast. Each of these address types serves a unique role in facilitating communication in different network scenarios. To kick things off, let's start with Unicast addresses. These are the most common types of addresses you'll encounter in IPv6. A unicast address represents a single interface within a network. When a packet is sent to a unicast address, it is delivered to the interface identified by that address. It's a one-to-one communication model, kind of like sending a letter to a specific home address. Next up, we have multicast addresses. Unlike unicast addresses, multicast addresses represent a group of interfaces, typically on different nodes. When a packet is sent to a multicast address, it is delivered to all interfaces in that group. It's a one-to-many communication model, similar to broadcasting a message on the radio. Last but not least, we have Anycast addresses. These are a bit tricky. An Anycast address also represents a group of interfaces, but here's the catch. When a packet is sent to an Anycast address, it is only delivered to one, the closest one in terms of routing distance. It's a one-to-nearest communication model, somewhat like dialing a customer service number and being connected to the nearest call center. Now that we have a basic understanding of the three main IPv6 address types, let's delve deeper into their unique characteristics. What sets unicast IPv6 addresses apart from the rest? Now that's a question that deserves a comprehensive answer, and here it is. Unicast addresses are like the VIPs in the world of IPv6 addresses. They're designed for one-to-one communication within a network. Think of them as the private phone numbers of the internet world, where each device has its own unique number. This uniqueness is the key to their role in IPv6. In the grand scheme of networking, unicast addresses shoulder the responsibility of facilitating direct and exclusive communication between devices. They create a private line of communication, if you will, between the sender and receiver. But what makes them so special? Well, the answer lies in their structure. A unicast address is made up of two parts: a network prefix and an interface identifier. The network prefix, which is usually provided by an internet service provider, identifies the network a device belongs to, while the interface identifier, which is derived from the device's hardware, uniquely identifies the device on that network. This combination of network prefix and interface identifier ensures that every unicast address is unique. It's like having a street address and apartment number. The street address helps locate the building, and the apartment number identifies the specific unit. Similarly, the network prefix locates the network, and the interface identifier pinpoints the specific device. Now, why is this important? Because it allows for efficient routing of packets on the internet. When a packet is sent to a unicast address, the network knows exactly where to deliver it. There's no confusion, no delay, just swift and accurate delivery. So, in the world of IPv6, unicast addresses are the backbone of individual device identification and communication. They're essential for maintaining the smooth and efficient functioning of the internet. With an understanding of unicast addresses, we can now appreciate their role in facilitating unique device identification on a network. And that, dear listeners, is the beauty of unicast IPv6 addresses. How do multicast and anycast addresses contribute to efficient network communication? Now let's dive into the world of multicast and anycast addresses in Internet Protocol version 6 or IPv6. These addresses play a critical role in ensuring efficient network communication. Let's start with multicast addresses. In the realm of networking, multicast addresses are like the town criers of old. They shout out messages not to just one person, but to an entire group of devices on the network. This ability to transmit data to multiple devices simultaneously is what sets multicast addresses apart. With multicast, a single packet of data can be sent to a group of destinations in a single transmission. It's akin to broadcasting a radio show. The DJ does not send individual messages to each listener. Instead, the broadcast goes out, and anyone tuned into the frequency can hear it. On the other hand, Anycast addresses work a bit differently. Imagine you have a group of servers, each capable of providing the same service. An Anycast address is assigned to this group. When a client needs a service, it sends a request to the Anycast address. The network then routes this request to the closest device within that group. This ensures a quicker response and efficient use of resources. It's like hailing a taxi in a bustling city. You don't care which taxi you get, as long as it's the nearest one that can get you to your destination quickly. In summary, multicast and Anycast addresses each serve a unique purpose in network communication. Multicast addresses allow for efficient data transmission to multiple devices simultaneously, akin to a radio broadcast. Anycast addresses, on the other hand, help in delivering data to the nearest device in a group of potential receivers, similar to hailing the nearest taxi in a busy city. Multicast and Anycast addresses take network communication to a new level by allowing for efficient data distribution and nearest device communication. And with that, we've wrapped up our discussion on multicast and Anycast addresses in IPv6. How do IP parameters influence client OS networking capabilities? Let's dive right into it. Every network-capable device, from a humble smartphone to a colossal data center server, operates under the influence of certain parameters. These are the IP parameters, and they are fundamental to the client operating system or client OS. Imagine a city sprawling with buildings and businesses. Each building has a unique address, a specific route to reach it, and a postal service to deliver mail. Similarly, each device in a network has a unique IP address, a default gateway, and a domain name system, or DNS server. These are the core IP parameters of a client OS. The IP address is akin to a building's unique location. It's a numerical label assigned to each device participating in a computer network. This address is used for identification and allows devices to communicate with each other. The subnet mask, on the other hand, determines which part of an IP address is the network address and which part is the host address. It's like knowing which part of a city you're in and which specific building you're looking for. The default gateway is like your city's main highway. It's a device that forwards traffic from the local network to other networks or remote sites. When a device wants to communicate outside its network, it sends the data to the default gateway. Finally, we have DNS servers. These are like the postal service of our city analogy. DNS servers translate domain names to IP addresses. So when you type a website name into your browser, the DNS server translates it into the IP address of that website's server. So, these IP parameters, the IP address, subnet mask, default gateway, and DNS servers form the backbone of every client OS. They determine how it communicates within its network and with other networks. Understanding IP parameters is key to configuring and troubleshooting network issues on a client OS. They are the building blocks of networking, and without them, our digital world would be a lot less connected. How can you verify the IP parameters of a client OS? That's the question we're tackling in this segment of our journey through the world of IP addressing. To begin, let's understand what we mean by IP parameters. In essence, these are the key characteristics of an IP configuration, including the IP address itself, the subnet mask, the default gateway, and the DNS servers. All these elements play pivotal roles in ensuring smooth network connectivity. Now, on to the crucial part, the verification process. This mainly involves using command line tools that allow us to peek into the system's network configuration. For Windows operating systems, ipconfig is your go-to tool. Running ipconfig in the command prompt will reveal a wealth of information about your network interfaces, including IP addresses, subnet masks, and default gateways. For Unix-based systems like Linux or macOS, ipconfig is the equivalent tool. It provides the same information as ipconfig, just wrapped in a slightly different format. Another handy tool for verifying IP parameters is ping. This utility helps determine whether a specific IP address is accessible. It sends a small packet of information to the target IP address, then waits for a return packet. If received, it indicates that the network path between your system and the target IP is functional. While these tools might seem simple, they are incredibly powerful diagnostic aids. If you're having trouble connecting to a network or a specific website, the first thing to check is your IP parameters. These command line tools can quickly tell you whether your system's IP configuration is correct or if there's a problem that needs addressing. Remember, the world of networking can be complex and intimidating, but it doesn't have to be. With the right tools at your disposal and a solid understanding of IP parameters, you can confidently navigate through any network issues that come your way. With the right tools and knowledge, verifying IP parameters becomes a simple task that can save you a lot of troubleshooting time.